Oh, what do you have?
Yeah, I got it. It's my fortune.
So I did 56. Like on like the screen, like you was like 4 and 7, and I keep getting this, and it does not factor. So like it's using numbers and like it's not getting either.
See, that makes me nervous. He's like the smartest kid in the world. He's like the smartest kid in the world.
Yeah, I do have an answer key up with all the work on it.
Okay.
So you can also look at. All right, I want to go through a couple key ones. Test tomorrow with the 12 questions. Listen up. They're all worth 8 points, except 2 are worth 10, so that gives me a nice even 100. There's partial credit. One thing here about in pre-calc honors, we don't do practice tests, so I'm not going to give you a practice test which is exactly the same as a test, except for numbers have changed. We're going to up the ante a little bit here. You're going to have to go back and review some things, but the review is very representative of the test. Okay. So we do try to cover everything, and we'll go through some things in class and then those problems on review as well. There'll be no just straight factoring problems. You will have to factor within other problems, but it won't just say factor and be done. Like if you have to solve a quadratic, you might have to factor there, or a radical equation might have factoring in it, but there will just be no. So you don't have to worry about sum or difference of cubes. That's not going to be on there. Okay, do not worry about those. All right, let's go through here. I think the answer is -8. Y to the 17 over 27, x to the 16, z to the 5th.
Yeah.
All right, so let me just run through that real quick. Here's what I would do. That's squared. I'm going to move this down below. And in doing so, I'm just going to put whatever's down there in parentheses just so that they don't overlap with each other. So -2x cubed, y to the -4th, z squared. And then that gives me 3x cubed, y to the -1st, z, all to the third power. Okay, for that one. Now I'm going to take the powers to a power. And then that, what does it give me here? It gives me 16. X to the -4th, y to the 10th over -2x cubed, y to the -4th, z squared, and then that's 27, x to the 9th, y to the -3rd, z to the 3rd. Multiply these two together just to get the powers here. So I got 16, x to the -4th, y to the 10th. -2 times 27 is -54, x to the 12th, y to the -7th, and z to the 5th. All right, the whole problem is going to be, first of all, examine, is the whole final answer going to be positive or going to be negative? It's got to be what? Negative. And then just either move the negative up to the numerator or put it out in front. Don't leave a final answer with a negative in the denominator. Not that I'm going to mark it wrong. It's just not very mathematically nice. And this reduces by 2, 8 over 27. So it's going to be -8 over 27. -4 minus 12 is -16, which moves down below. 10 minus -7 is 17. Z to the 5th. Okay. All right, on the homework. Whoops. We'll go to that in a second. I looked over the homework. A few of you that submitted it, not too long ago. I still have to get through theirs, but I didn't see anything glaring. But that doesn't mean you don't have questions. Anybody have a question? You got to know, is it going to be less than or the absolute value? When it's less than or equal to, you got to break it up into 2 ands. If it's greater than, you got to make it 2 ors. And so hopefully you double check your answers. But any questions on any of those homework problems? All right, if you turned it in within the last hour or so, I still have to get it. We're gonna go through about 3 or 4 here together, and I'll give you the rest of the time to work on that review. I do have an answer sheet for the review with the work on it as well. But let's go ahead and take a look at this one. Goldsmith has 60 grams of a gold alloy containing 60% pure gold. How much of an 80% alloy must be added to obtain an alloy that is 75% pure gold? Some of you are definitely fine with just creating the equation, but several of you also like to do a table. So I'll go with the table for that one, for this one. I'm just going to call this alloy 1, alloy 2, final alloy. Amount, percent, pure gold. All right, set up what you need, so I'll do here in a second. If you think you're good, move on. Okay, let's see what you got. The answer is 180 if you're that far. The answer is 180 if you're that far. So, but here, amount. We know you have 60 grams of the 60%, which is 0.6. And I'll fill in that last one here in a second. Alloy 2 says how much of an 80% alloy? You don't have any idea how much of that is. So that's got to be X, and that's 0.8. And we want the final alloy to be 75%. Well, you always have to add, to get the final alloy, you have to add those two together. So it's either 60 plus X or X plus 60, that doesn't matter on there. Now the pure gold is always percent times amount. Okay, we've been kind of harping on that a lot, percent times amount. 0.6 times 60, 0.8 times X, and this is 0.75 times X plus 60. This is where we get our equation, that last column. 0.6 times 60 plus 0.8 times X equals 0.75 X plus 60, okay? Each one's different. Sometimes you're given the final amount, like you need to make whatever 25 grams of the 75%, but this time we don't know the final amount, so you have to do X plus 60. I believe this is 36 plus 0.8X equals 0.75X plus, what is that, 45? Okay. Now you're good as long as you don't make, obviously, a arithmetic mistake here. Subtract 0.75X. Oops. That gives me 36 plus 0.05X equals 45. Subtract 36. 0.05X equals 9. divide by 0.05. And that's where I believe we get the 180. Okay, so 180 of, what did we say, 60%? No, 80%. When you have this, when you're combining, so the first one has 60% plus 80%. You need to realize that the final mixture has to be between 60 and 80. It can't be over 80, it can't be under 60. Okay, so it has to be stuck somewhere in between that, in terms of that. So the smaller one, it has to be bigger than the smallest percent and smaller than the larger percent for that one. All right, so there's a mixture one. Completing a square. Gotta know how to complete the square. And I'll go through this as well. All right, so completing a square on this one, first step, you have to isolate that 5. Move it over to the other side. So I get 4y squared plus 12y equals positive 5. You cannot have a constant in front of a y squared. So to get rid of it, you divide each piece by the 4. So divide by 4, divide by 4, divide by 4. That gives me y squared plus 3y. Keep it as a fraction. Don't mess with it. Don't make it a decimal. Everything has to be in fraction form. All right, and this is where you complete the square. Take a second. You know what to do. See what goes in that spot. If not, I'll go through it here in a second. And we have to add that same thing to both sides. All right, you always take half of the coefficient of the linear term, the 3y, so you take half times 3, which is 3 halves. That number is what's going to come back later when we factor. If you recognize that, that saves you a little bit of grief. Okay, that's going to come back. We still square this. 3 halves squared is 9/4. That is what goes in each of these spots here. 9/4, 9/4. Okay? So you got y squared plus 3y plus 9/4, and I'm going to add those together over there, and that gives me 14/4. These will factor. This will factor into the quantity y plus 3 halves squared. This is where that 3 halves comes back. When you factor it, it's what's going to go here. Equals 14/4. Once you get to there, that's where you square root both sides. So square root y plus 3 halves quantity squared equals plus or minus the square root of 14/4. So I get y plus 3 halves equals plus or minus. The square root of 14 doesn't simplify, but the square root of 4 is 2. You need to do that. You need to make sure that you simplify where appropriate. And now move the 3 halves over, and I get y equals negative 3 halves plus or minus square root of 14/2. This is fine. You can leave it like that. You do not need to make it one fraction. If you do, that's okay as well. If you want to leave this, some people will say, well, what about y equals? Then that's the same thing. Yeah.
Can you go back up for a second? How do you get to the y plus 3/2 squared?
This one?
Yeah.
Okay. Where are we at? We are at y squared plus 3 halves, no, plus 3y, sorry, plus 9/4, right? And we got to factor that. It factors into two things here. Well, from trying to teach you a little bit of things here that this number, whatever you take half of, will always go there. But now you still have to satisfy the case. It still has to multiply to give you 9/4 and that to give you 3. So you could go through that, and then to multiply to get 9/4 would be 3 halves and 3 halves, right? 3 times 3, 2 times 2. But what's 3 halves plus 3 halves? 6 halves, which is going to be 3. It still follows our rules, but yet the shortcut, I guess, is if you recognize it, it's always going to be that term right there. Okay. But you can still go through the process for factoring. Okay. All right, we good on that one? All right, so you got completing the square. We did a mixture one, and I know by request here, a lot of people enjoy doing these, so we'll go over one. You're welcome. All right. And I'll go through it here with you. I'll go through it with you. All right, a couple key things. Whenever you have radicals, you must check for extraneous solutions because you will square at some point. Okay. You want to isolate one of the radicals. You don't want to mess with this right now and try to square both sides. So I'm going to move the minus one. I'm going to add it to both sides. And that gives me square root of 7x plus 1 equals 1 plus the square root of 5x plus 4. And once you get to that point, you've got to square. Now remember, especially on that right hand side, you got to put put an umbrella. You got to encase and then square. You cannot square individual pieces. So square root of 7x plus 1 quantity squared equals the quantity 1 plus 5x plus 4 squared. All right, left hand side. I can do that one. That's just 7x plus 1. I'm gonna write the right hand side out for just because it's for notes. Do as you need to do. Okay, so it's FOIL problem. Seven x plus 1 still on that left-hand side. When I FOIL, I get 1 times 1, which is 1, plus square root of 5x plus 4, plus square root of 5x plus 4. Plus, now when the two square roots are multiplied, you're just left with what's on the inside. Combine like terms there on the right. So I get 7x plus 1 equals, what is that, 5x plus 5 plus 2. When you add those together, you get 2 square root of 5x plus 4. All right, I'm just letting everybody get caught up. Okay. All right, do we know where we're going from here? Okay, once we get to this point, you want to isolate this square root again. So I want to subtract 5x. I want to subtract 5. 7x minus 5x is 2x. 1 minus 5 is negative 4 equals 2 square root of 5x plus 4. All right, now pay attention here because this is a little bit different than last time. You do have to square. And I said if there's a constant in front of that radical, you can divide if it gives you nice numbers. Will dividing here work? Yeah, you got a 2x minus 4. I'm going to choose to divide. You'll still get the same answer if you don't, if you just square it from here. But it just makes life a tad bit easier. So 2x divided by 2 is an x. And we get a minus 2 here. And then you get the square root of 5x plus 4. If that number in front was a 3 or a 5 or something that didn't divide into it evenly, I would not divide it, leave it over there and then square it. And now I got to square again. X minus 2 quantity squared equals the square root of 5x plus 4 quantity squared. This is a FOIL problem. I'm just going to FOIL in my head. Get x squared minus 4x plus 4. And then that is 5x plus 4. You got a quadratic. I subtract 5x. I subtract 4. And I get x squared minus 9x. But the plus 4 minus 4 add up to 0. Okay. So it equals 0. Don't forget this isn't bad. That's not bad. I know you've been trained to have that trinomial factor in two binomials, but that's okay because you have a GCF of what? X. Factor that out. Factor that x out. And so we get two options. We get x equals 0 and x minus 9 equals 0. Sometimes one works, sometimes both work, sometimes neither works. You've got to test them. So take them back up to the original. And usually you can do it mentally, but it shouldn't take too much. And see which one works or maybe which one doesn't. And does 0 work? I didn't think so. 0 does not work because 9 works, right? X equals 9. Okay, and make sure it's clear. You identify where. All right, I also talk about on the test, these are some complicated problems. You want to get through here. And if you make a mistake, try to fix it, but don't spend too much time. You cannot become fixated on one problem. And then go through the whole test and then go back and check answers. Do not check everything from the beginning to the end. If you know what you're doing, you might get done with 20 minutes to go. Okay. Some people might work the whole time. Just depends. If you don't make any mistakes and you're moving and you do good, there's plenty of time. If you make multiple mistakes, you have to go back and fix. That's when you run into some issues. All right, the review. I'm going to do 21 together just because a lot of people end up missing that, and I just want to make sure you know how to do it. If you already did it, great. This is the review. I'm going to give you the rest of the period to work on it. On Canvas, under modules. I have the answer key to this. So for me, it looks like it's the chapter 1 review key. All the problems are on there. Everything's, even all the work shown. And I think most of them are right. The only thing is the very last one. It was getting a little tight on room, so I kind of crammed it in there. But everything else should be in there. Hopefully you can follow it. This will be available till tomorrow, right at the beginning of first period. Then I'll shut it down. Theoretically, at home you can print it off. I don't think you couldn't, but just through tonight, though. All right, let's take a look at what number did I say? 21? Okay, that one tends to be a struggle sometimes. And I want to show you a couple things. Solve. Got it.
T equals 2b over b minus 1.
T equals 2b over b minus 1, correct?
Yeah.
Solve that for b. Okay, very common thing that comes up is when you have a formula, an equation, and you have the variable you're solving for in more than one term. First of all, get rid of the b minus 1, multiply both sides by b minus 1. So we got t equals 2b over b minus 1, and we'll multiply both sides by b minus 1. And And so I get t times b minus 1, those cancel, equal 2b. All right, distribute. All right, there's two kind of paths you can take. Both are fine, but the answers will look slightly different, but I just want to talk through it. All right, right here, take a look where we're at. We're on the here on the left side, 2b minus t equals 2b. If I am solving for b, you have to get all the terms of b on one side. So Aaron, I'll let you tell me what we're doing next. We got to get, how are you going to do that? I got to get every term with a b on the same side. Which way are you moving things? Yeah, not sure? Okay, how many terms have a b? Two. Get them on the same side. So you either need to move the 2b over here, or we need to move the tb over here. Depending on which way you move them, depends on how your answer will look. All right. So for this one, let's move the tb. Okay. Subtract tb, subtract tb, and I get negative t equals 2b minus tb. All right, what's the big step here we got to do?
Pull out the B.
Pull out the b. Factor out the b, so GCF, so you get negative t equals b times 2 minus t. All right, now we're going to divide. 2 minus t, 2 minus t. So I'm done, and b equals negative t over 2 minus t. Perfect. That should answer good. If you look in the back of the book, that is not the answer in the back of the book. This is one where you don't need to go and change everything. This answer is perfectly fine. I'll explain how and why here in a second. So that's good. But like I said, if you look in the back, it's not the exact same thing. All right, now I said there's two directions. If you take and you subtract the TB, you moved it to the right, you got this answer. Well, some people look at this and, well, I'm going to subtract 2B. I'm going to do this. And you can watch, copy it down, it doesn't matter. But you get TB minus 2B equals T. Whoa, hold on. I kind of jumped a step there. Sorry. Minus T equals 0. Well, I got to get the TB and 2B on the same side. I got to get the other one over there, so I need to do what? I need to add T. Now, some of you would probably do it all in one step, which is fine, but I get TB minus 2B equals T. Factor out the B. Okay. Now, divide by T minus 2. Hold on here. Divide by T minus 2. And so I get B equals T over T minus 2. All right, that's the answer in the back of the book. Okay? The only other time is like there's fewer negatives, so it looks a little nicer, but it's not any better than this answer. How do you know? How can you look at, you have this answer, you look that up, how do you know you're okay? You don't need to change anything. Okay? What's going on is everything here is the opposite sign. You notice that? As long as that, you're fine. So this is a T. Well, I got a minus T. T minus 2, well, if you flip the signs, that's a negative and a positive. That's the same as 2 minus T. So if everything's the same except it's been negated, you're fine. You don't need to switch anything. Okay? So not a big deal. I just wanted you to make sure we went through this one. All right. Go ahead, work through the review. You got the answer keys on there. If you got any questions, I'll be up here. Ask Sue here. If you need to ask a classmate, that's fine. All right, but test will be tomorrow. You do not have to turn it. You do not have to turn in the review. Okay. You do not have to turn in the review.